Good afternoon, guys. There's a lot of empty seats. If anybody wanted to move forward, wouldn't be offended. I apologize, my voice is actually recovering. I lost it a couple days ago, which is bad news for you guys because we were actually going to sing this whole thing Las Vegas style. So maybe that's actually good news, I'm not sure. But, thanks for coming so late in the day. I'm Denver Maddox, the CEO of Megaport. This is Cameron Daniel. He's one of our founding engineers and basically responsible for the network at Megaport. We're here today to talk about, as the subject says, elastic banding in a cloud computing world, which really is about Megaport's mission to greater align networking and cloud computing from a provisioning and economics perspective. Cameron and I both have extensive backgrounds in building big networks, from Global Crossing in lives past for me, Limelight Networks, and Microsoft for several years. And have a lot of experience in living through the pain of building a big network and provisioning and having to buy a lot of lead time capacity in order to meet the needs of your clients, your demands, your workloads. And it's really time for some of that to change, so that's one of the things that we hope we can share with you here in our Megaport presentation. You want to add anything to that? Okay, great. So what is Megaport? How many have actually been by our booth? We have one, I know there's 3 of you at least, okay. We do have a booth where we're actually showing some demos and talking a little more in depth about Megaport, but Megaport is a network that is Australian today. We actually just opened our site in Auckland today. Actually, it just went operational. And we're about to open up our Hong Kong and Singapore locations. It is an SDN-based Ethernet fabric with a service layers to better align cloud service provider on-ramp for private to public cloud computing. One of the things we're trying to really accomplish with the platform is a harmonization across workloads in data centers, cloud. We've got content providers that are on the platform as well, and then other network service providers, from long-haul capabilities, IP transit, paid peering, and internet exchange services on the platform as well. We have a real-time portal that allows people to actually provision services once they've actually connected to Megaport, and really believe heavily in a completely automated self-service model. So we have a couple customer examples we wanted to roll through that actually we think highlight some of the challenges that any retail or commercial or enterprise network would have in terms of provisioning bandwidth, connecting to the cloud, or dealing with the physicality of the world that is networking. So our highlight, first one is JB Hi-Fi, which, has anybody heard of this company before? Yeah, they're basically the Best Buy of Australia. A huge retailer, fairly large market cap, really specialize in phones, TVs, that type of stuff. They had some very specific issues to solve in terms of getting access to private to public cloud on-ramp, getting access to some BCDR capabilities. They are based in Melbourne, which is one of the southern capitals in Australia, and working with a very high-cost IaaS provider. And they had some extremely high costs to get VPNs into AWS in Sydney, and they had a large issue in terms of replicating a database. And one of the reasons several of the reasons they wanted to move, just don't leave that one yet. One of the reasons they wanted to move to AWS Direct Connect was drive their costs down, which there is an opportunity to do that, add some redundancy into their network, and then be able to have the scalability of network capabilities into AWS based on the seasonality that they have. Retailers have this problem, and those of us that have served a lot of different network profiles see seasonality in terms of holidays or buying seasons, or people are back in school or they're not in school. And so they want to be able to account for that change in their demand sets. So that is one of the benefits of our platform. Let's move to the next one. So the question in physicality for them was, they're in Melbourne. AWS in Australia is in Sydney, particularly in the Equinix facility in Sydney. And what it would take for them to get from Melbourne to Sydney was a fairly complex set of negotiations for local tails, some long-haul services, and then termination of those long-haul services in Sydney into the Equinix facility there. So one of the things that we can solve, because Megaport has facilities in Melbourne and Megaport in Sydney, we actually have network capabilities to connect a Megaport to a Megaport scenario. So for them, it was a matter of connecting to AWS through their Megaport. AWS is terminated in Sydney, and then we can stand up a circuit and solve that for them with one virtual cross-connect effectively between large geographies. So moves all the other physicality out of the way for them. They don't have to worry about figuring out how they're going to do that. They take a port from us in Melbourne, and they go to the portal, log in, and configure that. And we'll walk you through how we can configure that later in the presentation. One of the other issues they had was elasticity. It's very easy for us to know what we need today, and hopefully we've built for what we need today. But anybody who's done any long-term forecasting understands it is really complex to know, what am I going to need in 30 days? What am I going to need in 90 days? And some of us had hired some rather large groups of data scientists to sit around and do forecasting models and figure out what the probability was of landing on the right amount of bandwidth, the right amount of compute capabilities, the right amount of storage. And in the cloud computing model, it's really easy to say, I need a bunch of storage in this period of time, but in 6 months I'm not going to need that, so I know I can scale that back down to some other reasonable number that works for me and save a bunch of money. And the network has not necessarily followed suit to that in many ways. Typically you're stuck in a 12, 36, 60-month contract. You're you're actually reserving a bunch of bandwidth that you may or may not use, which may sit highly unused for large periods of time. And so one of the challenges with that is getting your forecast right. Or if you know your forecast is going to turn down, eating the fact that you're going to have a bunch of costs that are just basically money out the door for something you're not actually using. So with Megaport, one of the things we can actually accommodate is that flexibility. With the scenario that they enabled from Melbourne to Sydney, they were able to basically say, well, for this period of time, I need X number of megabits or gigabits per second to get to AWS. And then when that turns back down, they can log back into the portal, reconfigure and downsize the size of their virtual cross connects, and then bring those back up at any time based on whatever demand there is. So benefit there, clearly a cost down scenario as well as commercial flexibility. For us, there's not a contract for these services. They can order them on, until very recently, only daily and monthly. Now we've opened up hourly and weekly billing as well. So if people want to stand up X megabits or gigabytes transferred over some period of time, they can stand up a virtual cross connect for 6 hours at the middle of the day, whenever they want, and just pay for that time that they use it. And then, of course, the issue of manageability. Just to touch back on the simplification of their connection from Melbourne to Sydney on our platform, it's a complex world for them to go and navigate, and not having a bunch of network experts in-house. The prospect of having to go along all the lines of network configuration, have to be responsible for the cross-connect in a data center, for the local loop to reach a service provider that maybe they want to use to get from Melbourne to Sydney, to pay for that long-haul connection, and then whatever they have to do on the other side of that connection as well in Sydney. We simplified that and just remove out a bunch of the other contracts, service fees, install fees, and all the sort of stuff that is, frankly, kind of a headache around building a network. Next, we worked very closely with what is probably the largest data center operator in Australia, NextDC. NextDC has locations in, as it says here, Sydney, Melbourne, Perth, Canberra, and Brisbane. And they are very along the lines of Equinix, but they're the dominant player in Australia. And what they didn't have in their facility was access to AWS. we deployed Megaport into all their facilities in Australia. And we were also deployed in Equinix alongside AWS. Being an AWS partner, we were able to just basically extend their footprint from their locations and their customers' footprint into getting access into AWS. So for us, it's just a matter of getting past the physicality. They don't have to worry about it. Since our platform's in their facility, we have dark fiber between our platform and their facility and in the facilities in Sydney. We've offered their customers basically access through Megaport to get access into AWS and extends AWS's coverage zone, extends NextDC's capabilities in that market as well. Anything to that? So, in terms of what we think is important for Megaport, there are really three key themes that we focus on. First of all, the internet is an ecosystem of, it's basically a series of addresses. It's not this big nebulous thing. It's literally a bunch of equipment installed at a bunch of addresses around the world, tied together with a bunch of dark fiber, and navigating that whole ecosystem is, it takes some expertise, and not every company has that, nor do they want to spend the time doing it. And we want to be able to solve that and make it easier for customers of Megaport. The next issue is, frankly, the way that bandwidth services are bought and sold is really, really old. It's outdated. Cloud computing has been revolutionary in terms of what it's allowed businesses to find in terms of scalable economics, scalable capabilities, from small, medium, and even into enterprise businesses. The ability for us to dial up and dial down what we need at that time for our business is hugely important. And networks have just not followed suit to that. And a lot of this is just historical burden, frankly, from billing systems or, that's just the way we get things done. Contracting and forecasting and basically the inflexible nature of that is something that just really needs to be updated. And that is one of the core missions for us, is to actually break away completely from that model in terms of how we do contracts if people want them, or month-to-month terms. Once you've actually gotten a port on the infrastructure, complete flexibility for how you utilize that bandwidth. And so we want to actually revolutionize that. Traditional model's fine if you don't mind the really long lead times. For us, for someone to get a Megaport, if you're in a data center where Megaport is, this is a cross-connect, which typically takes a couple of days. Our entire installation process is automated, front to back. So once somebody actually orders from us through the portal on Megaport, we actually configure our side, and it's just a matter of them getting their cross-connect terminated and just configuring on their side. They're going to get the data they need from us from an IP perspective or any other configuration details they need to know. So we break that right away. You don't have to wait for the long provisioning times. The carriers are waiting, and they're doing a great job at it. And if you have that time and you have that good forecasting, and you know you can get ahead of that demand, great. A lot of times we all end up with our pants down, frankly, and then something happens that we weren't expecting, and we have the ability to react quickly to that. If you don't mind long-term and flexible contracts, the old way works too. If you know that you have the ability to absorb those costs in your system, sure, take a 60-month contract. Live with that. It's okay. I've done it for many years. But when you aren't using it and your COGS are high as a result of that, or your effective cost megabit per second is really high, that's not a really great outcome for the business. And this is something we want to do away with. We don't have any installation fees. So most everybody else is dealing with a non-recurring fee from any network provider that they're ordering long-haul services from, or IP transit, either to pay for the port or pay for people doing some job. You're okay paying for what you don't need, and that's the empty seats we're talking about. If you order a 10 gig circuit and your average utilization is a gig, but you don't want to bond 10 gigs or 1 gigs together to get that gig of throughput, you're going to end up sitting on 9 gigs of capacity that's just not used. And with elastic bandwidth, you can turn that up and turn that down as you need it. And really, if there's no other options available, then by all means, if there's not a Megaport near you, which for those of you who aren't in Australia right now, and until we build in North America and Europe, that's probably not an option for you. But we have a demo we want to run through, and Cam's going to walk us through how to basically set up some services and some of the concepts behind Megaport.
Cool, thanks. So as Denver mentioned, I'm one of the network engineers at Megaport. I'm responsible for, so that means I'm responsible for the network infrastructure deployment, as well as some of the software that automates the service delivery and provisioning process. Before I start this, I just want to do a bit of an overview on what a service looks like, because we're an infrastructure provider, so that means we've got equipment in data centers. You buy physical network services off us. There's a lot of guys downstairs that they're selling software, so I just want to clarify that that's not us. A Megaport, so the service is split up into two key components that I'll talk about today. A port, which is a port in a data center, and a VXC, which is a virtual cross-connect, which is a circuit to another port on the network. In this context, we're talking about AWS. We've also developed the software in such a way that we want everyone to be able to use it the same way that we do. So we've developed a bunch of tools, a number of tools internally over the last probably 12 to 15 months. And we've wrapped them all up in an API that faces the world. And we've developed a web portal and some mobile apps that sit on top of that. The idea being is that we want people to get started using our tools, but feel free to step in and write your own. Some of the things we've seen people doing so far are integration with notification systems, with ticketing systems, and backup jobs, which I'll talk more about as I go through. So the first demo will be about the portal. So that's the web portal. It's basically, the idea is to make it as much self-service as possible. So we want everyone to be able to get out of the API and out of the web portal everything that they can get from their own network monitoring systems, be it graphing, ticketing, notifications, syslog, all the things that you get from your network today, we want you to be able to get from our system so you can integrate it as neatly as possible. Basically, we want to just be transparent. So probably the simplest way to show how it works is to order a service. This fits in nicely with the Amazon model as well, because I can show how we integrate with Amazon and Amazon's Direct Connect service. So here's the login screen. So we'll skip that because that's not very interesting. Stop skipping though. Anyway. This is the ordering screen. So basically, a VXC has two ends. So it has an A end and a B end. The A end is your data center. It's your facility. It's where you've got your equipment, be it whether it's on-premise, in a cage in a data center. This is where your stuff lives, and we want to order it to a remote destination. So in this instance, the partner port list is showing up. So you can see that we've got a number of partners, Amazon being the one we're talking about today, but we do some integration work with a lot of people. So all the cloud, this is obviously an Australian list, but all the usual cloud providers, voice providers, transit providers, the idea is that we'll work with these guys and we'll work with other service providers to integrate, to try and make it a one-stop shop, basically. So you can order a service on us, and we'll put onward orders onto their systems where we can. So where you can give us permission to place orders on your behalf, that's how we do it. So that's what we do with Amazon, and that's what we do with a couple of other guys locally in Australia, and that's what we're planning on doing in North America as well. So select Amazon from the list, and we'll pick a speed for the service. So because it skipped a couple of slides, so I'll just talk about the top. So up the top you can see it's probably big enough. You can see the AN port is a port I selected in Global Switch, which is one of the big data centers in Sydney, in Australia. Each VXC presents on a VLAN. So the underlying technology is MPLS pseudo-wires for the networking guys in the room. And we hand off each VXC as a VLAN ID. So you can have a VXC to, like Amazon on 304, and that's just what presents on your port. So you configure your switch for VLAN 304, and that goes to your VPC in Amazon. You could order a VXC to your transit provider on VLAN 305, a VXC to your voice provider on VLAN 306, and you just configure your network. You can have as many VXCs in the port as you like. We'll just pick a speed, 1.5 gigabits. The pricing in this example doesn't matter, it's the same. And because this is part of the integration we do with third-party providers, so when we selected Amazon, it showed up some extra options for Direct Connect. So we collect some details that are used to provision the Direct Connect portion. And then as you place the order with us, we then onward place the order onto your account in Amazon. Amazon don't do OAuth, so there's still an approval process that needs to happen on their side. So I'll talk about that in a moment. But we just ask for some details like account ID, whether you want a private or public virtual interface. So if anyone's not familiar with Direct Connect, what the product is, when you're connecting directly with Amazon, you run BGP with them, and they've got two different interface types. One basically connects to a VPC, so that's for your EC2, RDS, Elasticache, all the services that run inside of a VPC. And the public interface is for things like DynamoDB, S3, Glacier, Redshift that run outside of that. So there's a slightly varying details that we need to collect depending on which interface type you like. So that's all automated. Depending which one you click, some more options appear, but this one we're just going to keep it simple. Private virtual interface, automatically allocate the IP addresses. We'll also fill in the details for BGP, which is a routing protocol for the non-network guys. We need an autonomous system number and authentication key. Now we pick what billing option we want. So the demo, we recorded this a couple of weeks ago. Since then, we've announced that we're doing hourly billing, which will be there as well. The reason we differentiate, we don't just bill by the hour, but we differentiate the options is because the longer commit that you give us, the better price we offer. That helps us, plan our bandwidth. It helps you manage your costs. So I guess the key takeaway from that is that you can select how much you want to pay within reason, and you can select how long you want the service for. That lets us capacity manage, and it lets you manage your costs as well. So there are a number of options you can do around this. So you can see, I guess, from the pricing, and this is actually slightly out of date. So when I go to the next slide and select the service for a day, it says $20, but it's actually $10 now. So you can have a gigabit, 1.5 gigabits from your data center in Sydney to Amazon for $10. If you've just got to copy a bunch of data across, only going to take you a day to do it. It's a pretty easy business decision to make. We'll submit the order. Takes a second, and then it takes us to the service screen, and you can see the new service there. The light's still grey because it's not provisioned yet, but in the back end, the network's soft provisioning the service, placing the API calls onto Amazon. So you go log into your AWS console, you've got a new virtual interface request that you need to approve, linked to a virtual gateway on a VPC, and the service takes about a minute to provision. So by the time you've done all of that, it's ready to use. The way this is just pretty powerful in that you can do the same thing. So once you've provisioned the service, and I don't have this in the demo, so if anyone's wants to see any more of these examples, we're straight as soon as you walk in the hall downstairs. But you can do the same thing with modifying services, all your moves, adds, and changes. You can do everything. It all takes a minute, and depending on, as long as you're staying within the same metro, the cost doesn't change. So one of the other demos I'm going to do very, very quickly is just show how you can, just some of the API calls, what you can do, how to log in, how to list your services, and I'll talk about some of the ways that users are managed in the back end, which we think is pretty powerful as well in terms of people who are contracting for multiple companies. So sort of like your integrators will get some use out of this as well. So I'm a Linux guy, so this is just curl. It's not anything fancy. But basically, login's pretty simple. You post some form data to an endpoint. The pipes at the end are just to format the output, make it look pretty. The response object, it's a RESTful API, it's all JSON. The response object that you get from the login is kind of interesting because it contains some user data, where you are, what you're doing. A session token, which is used to authenticate, so we don't sign requests like the AWS one, it's a session token. But the permissions object at the top is where it gets kind of interesting. So this user is a member of company 203, and they've got those permissions. So basically, the user I've logged in is an admin user. But what you can do is we've got a concept of service groups that you can put users in multiple service groups, and service groups are owned by companies. For the developers in the room, it's probably a bit analogous to GitHub's organizations. So an organization is a company, essentially, and users can belong to as many organizations as they like. So that's how we've done it, which works for guys like integrators who may work with a number of customers. Their customers can add the services that the integrators work with to a service group, and then those users, and then give them permissions in the service group. So they can log in, and maybe they can log in to make service modifications but not see any financials, or they can order new services but not change existing services. The permissions are very fine-grained, and we've worked pretty hard on doing that. The idea is the reason we did that is because I've worked at a number of places, and I've got about 6 different logins to the Equinix portal, there's core site portal, same thing. I've got a million logins for all these portals. So we wanted to make it so people could come along to Megaport with one username, one password, and access everything that they needed to. So the next example, we'll just grab a list of services. So kind of extending what I mentioned before about users and service groups. I'll grab the list of services by my user ID, rather than the company ID, because I might be able to see services from 1, 2, 3, 5, 10 different companies. So this will, instead of having to query all those companies and find out which services I can see from each of them, I can just hit one endpoint and it'll tell me everything that I've got access to. So this is just a list of services. It's an array of service group objects. So you can see the various details. This is a pretty high level endpoint, so it just tells you what services that you're able to see, what their provisioning state is, what the date they were ordered. There's significantly more in terms of being able to view, and I can show you guys downstairs if anyone wants to come by the booth, to be able to see live service status. So you can ask, is the service up? You can ask how much traffic is on a service, what VLAN is the service on. You can schedule a date for it to be provisioned. You can schedule a date for a change to be made. So you can say, tomorrow night at 2 a.m. I've got a backup scheduled. So I want to take my 100 meg Direct Connect service and make it 5 gig. And then at 4 a.m. I'll be finished, so I want to take it back down to 100 meg. And you can schedule that either in our software or you can schedule it using your own tools. And that has quite a bit of power because obviously you can time your backup jobs and only pay for the bandwidth that you use as opposed to paying for the committed rate for the entire time. This is kind of a new model. It's a bit different from what the existing carriers are doing, but we do back all these services with the same SLAs that you get from your existing carriers. So we let you scale the bandwidth on demand to whatever number you want up to your port speed, but we still back it. We guarantee that we'll deliver all the packets. So we've got latency SLAs, packet loss SLAs, everything you'd expect from every other network provider. That's about it for the demos.
Yeah, I just wanted to add that one of the important parts about seeing the command line capabilities and actually doing querying or working with the API directly is that if you're programming jobs or you're building software to do specific workloads for you, you can literally incorporate into that development cycle access into Megaport and stand up and tear down VXCs as you need them through your work. So if you have a backup job that happens for a couple of hours every night, you can literally dial up a VXC through your backup job and then to rip it back down when you're done with your backup job. Yeah, so it can be fully automated from your end as well. It doesn't have to be going into a portal and clicking through buttons.
Yeah. So another example we've seen customers do. We've got a customer back home that's has a fairly large geospatial data sets. They're a big JS provider in gas. And so they've got a lot of software builds they've got to do. They develop a lot of software internally. So they've incorporated the scaling of the bandwidth in terms of they use Atlassian Bamboo for their CI tool. And they use whatever the feature is that lets you turn up EC2 instances to build. And they scale the VXCs into their build VPC as in time with the build jobs. So they can copy a bunch of data in, do all their analytics, do the build, run all their tests, and then scale it back down again when they've got the result.
Great. So, of course, being only in Australia probably is not super interesting to everybody, but we are in the process of kicking off a international build. Over the next 18 months, we'll be rolling into North America, Europe, and other markets in Asia. We're happy to discuss with anybody where they feel like they need the demand for this. We have a fairly intense knowledge set. Those of us that have built large internet infrastructure before generally know where we should go. There are the outliers in terms of new markets and basically new companies that are using cloud services that might be sitting in some different places than the typical internet community does. We're happy to hear from you guys. Hey, we'd love to see Megaport in Market X as well. And we can even share with you whether we're thinking about that or if we're not, when we should be. But we are expanding, and you will see us in a market near you soon. And that's pretty much it. Anybody have any questions or thoughts or anything? All right, thanks, guys.